In this video, we step back from the technical details and examine the differences in how the MIMIC clinical data model and the OMOP research common data model represent the same clinical data elements. I want to stress here that there is no data model that is best for all purposes. Each data model has strengths and weaknesses that can enable or inhibit the ability to extract and analyze data depending on the types of questions that are being asked. A key goal of the MIMIC-3 team was to capture data from various intensive care setting data sources and to retain those data elements as close to their original format and context as possible. The MIMIC-3 data model was constructed around the data sources present in a single healthcare institution, and by using different table structures for different data sources, MIMIC-3 is able to retain differences in the way the source data systems extract data. In distinction, OMOP was designed to support international multi-institutional data sets to support its initial mission as a worldwide drug surveillance system. To meet this goal, OMOP has spent considerable effort in creating a large library of harmonized terms that include terms from multiple countries. While the OMOP model has columns that retain the original data values, none of the OMOP tools or analytics use these columns because these terms are not standardized across all OMOP data partners. MIMIC-3 is a data set created exclusively from intensive care settings, or ICUs. It incorporates data from adult and pediatric ICUs and from specialty ICUs, such as neurosurgical and cardiac ICUs. Because of this narrow focus, there is minimal clinical information regarding events that occurred in the hospital outside of the ICU or in the outpatient clinics. One exception to this narrow ICU focus is MIMIC's extra efforts to capture all patient deaths, including those that occur outside of the hospital setting. In contrast, OMOP is designed to capture data from a wide range of clinical settings, including hospitals, clinics, and other locations using different values of visit occurrence type. In addition, OMOP allows for data that are not associated with a visit to be stored, whereas MIMIC requires all clinical data to be with either an ICU stay or with an ICU stay. MIMIC uses separate tables for different data sources, such as the MetaVision system versus the CareView system. These systems have different data representations and therefore have different data model structures in tables that are dedicated to storing data from these systems. In contrast, OMOP uses individual tables to store data that relate to the same clinical concepts merged from multiple different data sources. For example, there are many different types or sources that can assign diagnoses to a patient's clinical visit. An initial diagnosis is assigned during admission by the admitting nurse or physician. A final diagnosis is assigned by a physician when the patient is discharged or completes an office visit. Other professionals assign billing diagnoses that are submitted to insurance companies. Surgeons may assign diagnoses before and after a procedure. And more recently, patients have the ability to add their own diagnoses to a personal problem list. All of these different types of diagnoses are stored in a single table called condition occurrence. They are distinguished by a value in the condition occurrence type concept field. Similarly, different types of information about procedures are stored in a single procedure occurrence table. And, as we've seen, all medication-related data are stored in this single drug occurrence table. There is another key difference in how MIMIC and OMOP handle computed abstractions. Computed abstractions are data elements that are derived from other data elements in the database based on some standardized program that is defined by the data model. These standardized programs ensure that the computed abstraction is executed exactly the same manner in all instances of the CDM. In contrast, one-off abstractions are defined by the analytics team, and they can be different across projects or analysts. MIMIC has no computed abstractions in its data model, whereas OMOP makes significant use of computed abstractions. There are 4 main computed abstractions that are part of the OMOP data model. The observation period is the start and end date used to determine when the patient was under the care of a provider or an institution or a health plan. Drug eras and condition eras are a successive sequence of drug exposure events or condition occurring events, respectively, that form longer temporal intervals representing either the use of a specific medication or of a diagnosis or condition. Finally, the cohort computed abstraction is a set of patients that share a common set of characteristics, such as a common set of diagnoses or medications or procedures. Illustrated here is the concept of creating the computed abstraction for drug eras. Each row in the middle of the diagram represents a row of data for a patient in the drug exposure table. Notice how each of these drug events capture changes in medication names, medication amounts, or the duration of the exposure. The drug era computed abstraction combines these individual events into the longer lisinopril era 1 marked in the first green bar at the top. The drug era program defines a standard period of time called the gap interval that is used to determine when an existing drug era has concluded and a new drug era should be started. In OMOP, the standard gap interval for medications is 30 days. If there is no evidence of the continuation of lisinopril for 30 days, a new drug era, here labeled lisinopril era 2 in this example, is started when the drug exposure record is entered past the 30-day gap period. In addition, the key difference between MIMIC and OMOP is the absence of terminology hierarchies in MIMIC versus the extensive use of hierarchies to group terms into more specific subsets in OMOP. MIMIC is said to have a flat terminology structure, whereas OMOP is said to have a multi-hierarchical terminology structure. In summary, MIMIC is optimized to maintain the data integrity of the originating data source systems. It seeks to achieve zero information loss by leaving the data in the original format and terminology as it exists in the source system. This allows the data scientists to make whatever decisions regarding data harmonization at the time of the current analysis. Different data scientists may make different decisions regarding how to harmonize the MIMIC data for their needs. In contrast, OMOP is optimized to support large, international, multi-institutional, big data networks. It recognizes that transforming source data from its original format into a single standard term may result in the loss of data fidelity or specificity. In OMOP, data transformation is done only once by the local data owners. Data analysts only use the transformed data, accepting whatever mapping decisions that were made by the local data owners at that time the original data was mapped into the OMOP standard terminologies. As you can see here, the two data models are trying to achieve very different objectives and therefore have made different decisions about how best to represent the original data in their data model.